Right now, billions of miles from Earth, a machine launched in 1977 is still talking to us. Voyager 1 is now in interstellar space. But on November 18th, 2026, it is expected to reach one light day from Earth. A signal will take almost 24 hours to reach it, and another 24 hours to return. 2 days for one conversation. And that's not even the strangest part. In 2023, Voyager nearly went silent. Engineers had to fix it, from 15 billion miles away. September 5th, 1977, a rocket lifts off from Cape Canaveral, Florida, carrying a spacecraft called Voyager 1. At the time, nobody knows just how long this machine will survive. The mission seems simple. Fly past Jupiter, then Saturn, photograph the planets, study their moons and magnetic fields, and send the data back to Earth. But Voyager is built around one principle: reliability. There is no way to repair it once it leaves Earth. No replacement parts, no refueling, no astronaut can ever reach it. So everything has to work, or be designed to survive when something doesn't. Voyager reaches Jupiter in 1979, then Saturn in 1980. And after Saturn, the original planetary mission is essentially over. But Voyager doesn't stop. It keeps moving outward, past the planets, past the familiar solar system, into a region where almost no human spacecraft had ever gone before. Its power comes from radioisotope generators. They produce electricity from the heat released by radioactive plutonium. But that power slowly declines. Every year, Voyager has a little less energy than the year before. So engineers begin making impossible choices. Turn off a heater, save power. Turn off an instrument, save more. Every watt matters, because there is no way to replace what is lost. Then comes 2012. Voyager 1 reaches the outer boundary of the Sun's influence. The Sun constantly sends charged particles into space. This creates a vast bubble called the heliosphere. At its outer boundary is the heliopause. On August 25th, 2012, Voyager crosses that boundary. For the first time, a human-made spacecraft is directly measuring the environment between the stars. An interstellar space is not completely empty. It contains plasma, particles, magnetic fields, and turbulence. Voyager's instruments begin measuring this environment directly. One of its most valuable instruments detects extremely weak plasma waves. These signals allow scientists to estimate the density of the interstellar plasma surrounding the spacecraft. And the measurements reveal something important. The space between stars is not perfectly uniform. It has structure. It changes. It moves. Voyager is giving us measurements from a place we cannot study directly from Earth. That is its real scientific power. Not spectacular pictures, not explosions. Measurements. But then, in 2023, Voyager nearly went silent. On November 14th, the spacecraft stopped sending usable scientific and engineering data. The signal was still reaching Earth. The spacecraft was still responding to commands. But the information inside the signal was corrupted. Engineers eventually traced the problem to Voyager's flight data subsystem. A memory chip had failed. Part of the software was no longer accessible. And there was one enormous problem. They couldn't physically fix it. Voyager was more than 15 billion miles away. So engineers had to perform surgery. By radio. They divided the damaged software into pieces, moved those pieces into different areas of memory, and rewrote the instructions so the spacecraft could use them again. But every command had to cross billions of miles of space. A signal took roughly 22.5 hours to reach Voyager, and another 22.5 hours for the response to return. Nearly 45 hours for one complete communication cycle. There was no live connection, no instant feedback, No second chance. And somehow, they fixed it. By April 2024, Voyager was once again returning usable engineering data. By June, its remaining science instruments were sending usable scientific data again. A spacecraft launched in 1977 had survived another crisis. But the biggest enemy was still waiting: time. Voyager's power supply continues to weaken. Instruments have already been shut down to preserve the spacecraft, and eventually, there will not be enough power to operate the remaining scientific systems. When that happens, Voyager will not suddenly disappear. It will simply stop talking. And that brings us to November 18th, 2026. Voyager 1 is expected to reach one light day from Earth, about 16.1 billion miles, about 25.9 billion kilometers, a distance so enormous that even light needs an entire day to cross it. Imagine mission control. A problem appears on Voyager. Engineers develop a solution. They write the command. They send it. Then, they wait. 24 hours. Only then does the command arrive. And if Voyager answers immediately, another 24 hours pass before Earth receives the response. 2 days. A conversation between humanity and a machine becomes a conversation across time itself. And eventually, there will be no answer. But Voyager will continue moving. There is no atmosphere to slow it down. No road, no destination. It will simply continue along its trajectory through interstellar space. And attached to the spacecraft is something even stranger: the golden record. A gold-coated disc carrying sounds, images, music, and greetings from Earth. Thunder, wind, animals, human voices, music from different cultures. A small archive of the civilization that built the machine. It was never designed as a realistic conversation with aliens. It is something more symbolic. A message saying, "We were here. We looked outward. And we wondered what was beyond the horizon." That is what makes Voyager extraordinary. It is not the fastest spacecraft ever built. It is not the most powerful. Its computer is primitive by modern standards. Its energy is fading. And yet, it has traveled farther than anything humanity has ever sent. It crossed the heliopause. It entered interstellar space. It measured the plasma between the stars. It survived decades of radiation and aging electronics. And it survived a computer failure from more than 15 billion miles away. Voyager's greatest achievement may not be a single discovery. It is persistence. We built a machine almost 50 years ago, and it is still teaching us about a place no human being has ever visited. One day, the signal will stop. There will be no explosion, no dramatic ending, just silence. But silence will not mean Voyager stopped moving. The spacecraft will continue into the darkness, carrying its golden record, carrying traces of the civilization that built it. Long after the last engineer has gone, long after today's computers are forgotten, long after the people who launched Voyager are gone, the spacecraft will still be traveling. Voyager 1 is still out there, still moving, still measuring, still sending. And for now, the signal is still coming home.